Hello, my name is Uka Benjamin. Alright, you're welcome to another wonderful video. Okay, in the last video I did, we actually talked about how we could use our first part of our five-fold strategy to forecast the price of stock. But today we will be designing a deep reinforcement learning model and agent that will help in the optimization of carbon dioxide in your country, in my country, in the world as a whole. Alright, so what is actually this carbon dioxide? It is actually a colorless and odorless gas that is naturally present in the Earth's atmosphere. So we'll be optimizing a reduction system for it using deep reinforcement learning, because you see, one wonderful aspect about in data science or machine learning or artificial intelligence that will actually give you an edge as a data scientist is deep reinforcement learning. Deep reinforcement learning is actually is an aspect where there is an environment, there is an agent. This is not just the supervised or the unsupervised aspect of machine learning, but here there is an agent. You create an agent, and the agent is able to learn on its own and make decisions by interacting with the environment. All right, so this is it. On the screen here we have the agent, and then this is the environment, just like I showed us in this other picture. Yes, so this is, I had to create this picture using AI. So this is the agent and this is the environment, and there are some major causes of these CO2 emissions. One of them include fossil fuel combustion, deforestation, industrial processes, agriculture, transportation, and the likes of them. So let me put that on the screen again. So this is the agent. The agent will be taking action in this environment and then gets either a reward or a penalty for whatsoever action he takes. And then he will learn from the observation and then goes back again, take another action, receives a reward or a penalty. So the agent will continuously train itself, and like you see here, over time the agent develops a so-called policy and a strategy of action that promises the highest long-term rewards. And then in the first round, the algorithm selects completely random actions since it has not been able to gain experience over time. Okay, so like I stated here, it's actually a promising strategy. So let's get back to the next. So this is the agent, and then this is the environment. And so some things we'll be looking at this today is, number one, the emission of this carbon dioxide, and then other factors that also contribute to it and to the growth of this economy. Every other thing that contributes to making up this economy to what it is today, which involves weather, time, energy, industries, and so on and so forth. All right, that's not really my field, but as a data scientist, you find yourself studying and gaining vast knowledge. So, for every action it will take in this project today, we are trying to do this today, is actually morning here. It will get the following rewards. One of them is the reduction of carbon itself, like you can see the pointer. And then the next one is stability of energy supply. Stability of energy supply. And then we also get cost efficiency and then a renewable energy utilization. So these are the rewards. These are how we'll be rewarding the agents. But in a case where the agent does not take the right action, he will be penalized. And some of the ways we penalize the agent include penalizing it for high emission of fossil fuel, and also will penalize actions that will cause future failures, and also will also discourage financial inefficiency for energy production. Okay, let's get straight into the code. All right, so this is the code. The first thing we do, like we do in every work, is to import all necessary libraries. Take this off from the screen. And then you can see here we're importing pandas. Pandas will be used for handling the data set and analyzing the data set. So I have actually gotten this data set from Cargo. So you can go to cargo. I'll drop the link to this data set on the description, on the video description, so that you can get it for yourself. Now we'll be using pandas for data manipulation and to pre-process the data set. And also the next one there is Gymnasium. We'll be using the Gymnasium library. The Gymnasium library, sorry for that, is actually a library that provides simulation environment where the agents can interact and also learn and optimize good decisions. Then the next one there is our NumPy. We use NumPy for numerical computations, statistical calculations, and so on and so forth. Then also we're using the PPO for this, which is the Proximal Policy Optimization. Now, it's one of the best algorithms out there for DRL deep learning work. Okay, so the first thing, I actually explained it so well. So the first thing we did in this next block is to do every kind of pre-processing for the data set. So you see, I actually expanded it to make it more better for this work. So these are the codes. I'll drop the link to the data set, so and how we can actually get it. So these are the codes. We're using GDP growth, energy per capita, renewable energy, population growth. So these are the parameters we are using. And also these are the columns. So one of the things you must understand that in a case like this, min max scalar is what you should use for pre-processing your data set. So that's what I actually use. And then I had to define the environment here. So like what I was actually explaining, the length of environment is actually the beginning of the data set to the end of the data set. And then this is the action space. So it took a lot of time to do this. But I just want to show us the results. It actually went well. Okay, this is it. Let me start from the beginning. So when the agent takes the action, the first action here, like we see from the training, the reward was 0.77, so that is about 77%, and the action he took was to reduce the carbon dioxide directly. And then it suggested a policy that will focus on emission reduction through energy transition, and so on and so forth. Then the next one was to promote renewable energy and then increase investment in renewable energy sources. And then it gave the same 77.2%. So it actually did well. So this is a rollout. Then if you see the mean here, we got a very high amount and the reward is very high also. So you can take your time to really understand the meaning of each of these. I want to make this video so short, so I wouldn't explain each of these, but you can take a screenshot or write it down and then go to the internet, use your browser, get the meaning of this. It will actually help you. So at some point, we're getting losses about 15.9, but irrespective of the fact that we had this kind of loss for the value, we still had a very high reward. So we continued the trading, though it didn't take a lot of time because of the number of time steps that I used for it. So you see the time step here was 50,000, but if I am to deploy this model, I'll be using, let's say, 1 million or above. But I needed this work to be very short, and I needed this video to be very short also. So this is the evaluation. So I had to evaluate the model, and I called it. I actually saved the model. The function here also stipulated that the model would be saved. And you can also rewrite this code in a way that it will train, and in intervals it will save the best model and not just saving the model after training. and then you load the model, and then in a range of 1000 I had to run the model for prediction and then see what it actually gave. So this is the action it took over time, and then this is the average reward 0.77 or thereabout. So this is actually how well it performed, and I actually had to do a live prediction and then see the actions it took. The first one in a range of 10, the first it actually made an action which was the number 3, and then the second one was number 4, number 2, number 3, and I'll be showing us what each of these means when the agent takes the first action or takes action 1, action 2, action 3, or action 4. So okay, look at it here. So whenever the agent takes action 1, the agent is actually looking at reducing carbon 2, carbon dioxide 2 directly, that is CO2 emission, reducing it directly, and will suggest a policy which states that it will be better for the economy or for us to focus directly on reduction through energy transmission. And then the reward scale here was actually the highest. And then whenever the agent took the number 1 action, now it will be advising us to promote energy growth, economic growth rather, through sustainable practices, and whenever, just so on and so forth. And then for the 4th one would be to increase R&D expenditures, and the advice would be to pick up a policy like investing in research and development for green technologies. Alright, so in the next video I'm posting, I'll be doing something different. I'll be showing us how we can also use it to do health recommendation. And then after that health recommendation video, I will show us step by step how we can actually use deep reinforcement learning for fraud detection. Wow, I know you love that so much. So please, I want you to hit the subscription button, like, share, and follow. And if there's any project you want me to build or anything you want me to do for you using deep reinforcement learning, please drop it in the comment box. My name is Oka Benjamin. See you in the next video.